everyone, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of system of linear equations and matrices. So let us begin with the topic named diagonalization of a matrix. Okay. So let A be a square matrix of order n. The matrix A is said to be diagonalizable if there exists a non-singular. Non-singular means determinant should be not equal to 0, right? Non-singular matrix P such that P inverse AP is equals to D, where B is known as a diagonal matrix, right? So the matrix P is known as a modal matrix, right? So next, a n cross n matrix is diagonalizable if and only if it has n linearly independent eigenvectors, right? So it should have compulsory n number of linearly independent eigenvectors, then only a square matrix is said to be diagonalizable. Okay, so now let us study the working rule for diagonalization of a matrix A. Okay, so we have to begin with the first step. That is, we have to first find the eigenvalues of the square matrix A using our characteristic equations, right? Next, we have to find the eigenvectors corresponding to each eigenvalue using our formula A minus lambda Ix equals to 0. Okay. In the next step, we have to find the modal matrix P by writing the eigenvectors as its column vectors. Okay. And in the next step, we have to find P inverse AP, that will be equals to D, where D is the diagonal matrix which has eigenvalues as its diagonal elements, right? So let us understand this using one example. We have to find a matrix P that diagonalizes A, and also we have to determine the value of P inverse AP, right? So here we are given the matrix A as 2, 0, minus 2, 0, 3, 0, 0, 0, 3. Okay, so now let us start with the solution. So write the matrix A. Okay, now we have to first find the eigenvalues. But here you can see that our given matrix is of the form upper triangular matrix, right? So its eigenvalues will be the elements of the principal diagonal elements, right? So therefore the values of lambda will be equals to what? 2, 3, 3. These are your principal diagonal elements, right? So now our task is to find the eigenvectors corresponding to these eigenvalues, right? So firstly let us find the eigenvectors for lambda is equals to 2 using the equation A minus lambda Ix equals to 0. Now we know that our matrix A is given as 2, 0, minus 2, 0, 3, 0 and 0, 0, 3, right? So now we have to subtract minus 2 times I from A, where our I is given by 1, 0, 0, 0, 1, 0, 0, 0, 1, right? When you multiply these two, right, you will get 2, 2 and 2 over here. Now let us subtract these two matrices. So there will be only change in the principal diagonal elements. So what you will get? 2 minus 2. So answer will be what? 0. Now 3 minus 2. So answer will be what? 1. Next 3 minus 2. So answer will be again 1. Other all elements will remain as it is, right? Now let us write the equations from this. So the first equation will be minus 2z equals to 0. The next equation will be y is equals to 0. And the last equation will be z is equal to 0. So we have already found out the values of y and z. But we don't have the value of x, right? So what we have to do now, we have to suppose x as T1, where T1 belongs to R. Remember, we will always get homogeneous system and the solution of it will be infinite solution, right? So we have supposed x as T1. Now let us write our eigenvector capital X, which is equals to x, y, z. Now put the value of x, that is T1, y and z are 0. Now take out T1 common, so you will get 1, 0, 0. So now let us suppose y as T2 and z as T3, right? So where our T2 and T3 belongs to R. Okay, so your final answer of x will be equals to minus 2z, which will be equals to minus 2t3. Okay, now let us find our eigenvector capital X, that is equals to x, y and z. Put the value of x first, that is minus 2t3. Put the value of y, that is t2. And lastly put the value of z, that is t3. Okay, now in this, firstly we will separate the terms containing T2 and T3. So here we don't have T2, so it will come 0, then T2 and 0. Similarly, write the terms containing T3. So it will come minus 2T3, 0, and here it will come T3, right? Now what we will do, we will take out T2 common from this. So we will get T2 times 0, 1, 0 plus T3 times minus 2, 0 and 1. Okay, now we will assume this vector as x2 and this vector as x3, where our x2 and x3 are eigenvectors corresponding to lambda is equals to 3. Okay, so now let us find the model matrix P, right, that has eigenvectors as its column vectors, right? Therefore, P will be equals to, first write the eigenvector corresponding to lambda is equals to 2, right? So they are 1, 0, 0. Now write the eigenvectors corresponding to lambda is equals to 3. So they are 0, 1, 0 and minus 2, 0 and 1. Remember, in this always you have to write the eigenvectors in ascending order of the eigenvalues. So here we have first written the eigenvector of 2 and then we have written the eigenvector of 3. Okay. Now in order to find P inverse AP, we will first find the value of P inverse applying Gauss-Jordan method. Okay. So we will write this as P is equals to I3 times P, where I3 is an identity matrix of order 3 cross 3. So let us put the value of P and our identity matrix, right? That is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? Now in order to form identity matrix at this place, what we have to do, just one operation, that is we have to make 0 at this position. So which row operation we will use? R1 plus 2 R3. So you will get the first row as 1, 0, 0 and the next two rows will remain as it is. And here too you will get 1, 0, 2 and the last two rows will remain as it is. Okay, so here you have formed the identity matrix, here you have obtained the new matrix, right? So from this we can write it as I3 is equals to P inverse P, right? So comparing with this, we will get the answer of P inverse as 1, 0, 2, 0, 1, 0, 0, 0, 1. Okay, now let us find P inverse AP. So put the values of P inverse, matrix A and P. Okay, now multiply these three matrices. But whenever the matrix is diagonalizable, its answer will be what? D. And what is D? We have to write the eigenvalues in the principal diagonal elements in the ascending order, right? So you will get 2, 3, 3. So the answer of P inverse AP will be equals to what? D. Okay. Now in today's lecture we have studied diagonalization, right? So when a matrix A is diagonalizable whenever P inverse AP is equals to D, where D is our diagonal matrix, right? and P is known as, P is equals to what? Modal matrix, right? Okay, and the matrix A is also diagonalizable if it has linearly independent n number of eigenvectors, right? Next, what is the working rule to find the modal matrix P? So in order to find matrix P, firstly we will find the eigenvalues using our characteristic equations, right? Then we will find our eigenvectors. Okay? In the next step, we will find our modal matrix P. How we will find our modal matrix P? We have to write our eigenvectors, right, in the ascending orders of the values, right, of lambda, right? So after finding the matrix P, you have to find what? P inverse AP. That will be equals to what? D. Where D is our diagonal matrix. In this you have to write the values of lambda in the ascending order and other terms will be equals to what? 0. Okay. So I hope you have understood throughout the session. Thank you for watching.